When attraction starts, one chemical takes full control of your body: dopamine. The dopamine is the brain's go-get-it signal. It is the chemical that fuels our pleasure, focus, motivation, and craving. It's what lights us up when something feels incredibly rewarding. And now, add another ingredient. At the same time that dopamine spikes, serotonin drops. Serotonin usually keeps your thoughts stable and your emotions regulated. When it dips in your brain, order disappears and obsession starts to sneak in. And so, now you've got intense pleasure mixed with fixation. The result? A type of love that feels incredibly consuming and ridiculous, which explains a classic situation that everybody recognizes, and it's that you want the person who doesn't want you, and the person who wants you doesn't interest you at all. We've all been there, and that contradiction sounds philosophical, but it actually has a biological explanation to it. To get there, we first need to understand what love does inside of our brains. Imagine this setup. You walk into a college and recruit 2,500 students for a study. Each one goes into a functional MRI scanner, a machine that tracks brain activity by the second, and step 1, you have to show them a photo of a total stranger. Nothing special about that person. You record which brain regions activate when they see that photo. Step 2, you show them a photo of somebody emotionally close to them, a romantic partner or a close family member. Then you scan again. Now you place both brains side by side to the untrained eye. They look almost the same, of course, but when neuroscientists examine the brains, they said something unexpected happened between the two. Those two brains were fundamentally different. And this wasn't a hypothetical, it was a real study published in 2005 by Helen Fisher, Arthur Aaron, and Lucy L. Brown. But forget the names. What matters is what they found. They found that one of the main areas lighting up is the ventral tegmental area. This region is involved in pleasure, intense focus, and motivation, especially the motivation to chase rewards. Another area is the caudate nucleus, which helps your brain anticipate rewards and detect what feels valuable. Together, these structures form a part of what's called the reward system. This system exists for one single purpose only: to reinforce behaviors that feel good. Eating junk food, winning a game, achieving a goal, your brain remembers these pleasures and pushes you to repeat it. Early stage love plugs directly into this system, and during this phase, dopamine levels skyrocket. Cortisol, the stress hormone, also increases. Meanwhile, the serotonin levels continue to fall. That dopamine surge creates a state of euphoria that closely resembles the effects of stimulants. And that comparison isn't just theoretical. Researchers tested this idea using fruit flies. Male flies were split into two groups. One group was allowed to mate, and the other one wasn't. Afterwards, both groups were offered alcohol. The result? The flies that hadn't mated consumed 4 times more alcohol than the ones that hadn't, trying to reach the same pleasurable state. Love doesn't just activate pleasure circuits, it also suppresses negativity. Brain regions responsible for negative emotions become less active. Combine that with the halo effect, where one positive trait makes everything else seem perfect. Suddenly, the person you like appears flawless in your eyes. No red flags, no defects, just perfection. But here's the catch. If that love lasts longer than about 1 or 2 years, serotonin and cortisol levels gradually return to normal levels, and the emotional chaos settles and the obsession fades. And that's when you start noticing all the imperfections that person had and you ignored before, and the sole presence of that human being irritates you. The pedestal cracks, which is why long-term love feels calmer and why early love feels insane. So now you're allowed to go to your friend who's hopelessly in love and tell him, yo, relax, your ventral tegmental area is just going wild. So let's answer the original question. Why do you never like the person who likes you, but you always like the person who doesn't? Surprisingly, the answer isn't in psychology, but it's rooted in math. Let's create a simple scenario so you understand this very carefully. Let's say you regularly interact with 10 people you could potentially date. Out of those 10, 9 are just neutral, friends, acquaintances, nothing special. But one of them, though, is the person, the one you've liked forever, the one you idealize. By the way, if you're watching this and you're a woman, just flip the genders, it works exactly the same. Now, let's assume that you're reasonably attractive, and the chance that any given person is attracted to you is 20%. The exact number doesn't matter, what matters is the constant. The probability that the person you like is attracted to you is of 20%. But what's the probability of at least one of the 9 people you don't like and is attracted to you? Well, when you calculate it, the result is about 86.6%. that means that it's over 4 times more likely that someone you're not interested in will like you than the person you're actually interested in. And that's only with 10 people. Imagine in real life, you probably interact with 20, 30 or more, and usually you just like one. That imbalance grows even larger the more you interact with more people. But there is another problem with this model. It assumes that your attractiveness is equal to everyone, which of course isn't true. Compatibility matters, shared traits matter, context matters. You might desperately want that specific person, but if you don't align, the probability stays low. Meanwhile, someone else might naturally respond to you far more easily. So here's the real takeaway. You don't need more luck, you don't need better odds. And research says that there are 4 factors that increase your chances of that person liking you back. The first one is similarity, shared traits, values, or interests. If you don't bond with each other and you don't have interest with each other, there's nothing gonna happen there. The second one is familiarity, repeated exposure to that person. The third one is reciprocity, knowing the attraction goes both ways and it's not one-sided like some of the relationships you might know. And last but not least, physical attractiveness. And yes, physical attractiveness matters a lot according to science, but not in the way people think. It's not about being born handsome or ugly, it's about presentation, how you dress, your posture, your expressions, your non-verbal signals, because you can be as handsome as you can be, but if you're socially awkward, for example, people are gonna pick up on that, and the person you might like might pick up on that and feel completely unattracted to you because of this. And also, the bad news is that attraction is extremely complex as well. Even after decades of research, there are still variables we can't fully predict. So take this as a framework and not a formula. And that's all the science for today, guys. If you really liked the video, drop a thumbs up, subscribe down there in the video, and I'll see you guys in another science video. Take care.